students, good morning and welcome to Relief Tutorials. So in the last lecture we were discussing about refraction of light. We have seen that when one of the oblique light ray enters from one transparent medium to another transparent medium, speed changes, and due to this change in speed, the original path of the ray gets deviated, and this phenomena of bending of light ray is called as refraction. We have to study laws of refraction. Consider this is one of the surface separating two media, which is called as interface. This is first transparent medium, let us say medium number 1, which is maybe air or vacuum, whatever. Second transparent medium is here, maybe glass, kerosene, glycerine, diamond, whatever. So this is incident ray. Here is the normal, this is angle of incidence, and here is the angle of refraction. We have already seen the first law of refraction is incident ray, refracted ray and normal lies on the same plane. This law is same as the first law of reflection also. The second law is quite important. We were discussing this in the last lecture. The ratio of sine of angle of incidence to sine of angle of refraction always remains constant. The statement may be written mathematically like this, that sine I means sine of angle of incidence to sine R, sine of angle of refraction, always remains constant. I have told you that this statement is still incomplete. We have to find the value of this constant. What is this constant for? So today's topic is about this constant. Before going towards that, let us see one more topic is refractive index. Refractive index, a new word for you, totally new topic. So please be concentrated here. Consider this is the interface. Consider this is air medium above it, and let us say here is water. So one transparent medium air, another transparent medium is water. One of the oblique light ray goes from air to water. Air to water. We know the speed of light in air or in vacuum is 3 into 10 raised to 8 meter per second. Means 3 lakh kilometer per second. Water is comparatively denser medium compared to air. So water is being a denser medium. Speed of light will be less than that of the air. So speed actually decreases when the light ray goes from air to water. Consider this is point of incidence and this is normal drawn at the point of incidence. So when the light ray enters from rare medium to dense medium, the ray bent towards normal. So this is the original path and this is ray which is being deviated towards normal. So this angle between what? Incident ray and normal is angle of incidence, and here is what? Angle of refraction. We know these things. Here is air and here is water. Now one more comparison. Consider this is again one of the oblique light ray. The angle of incidence is same as that of this. Again this is air medium, but now here is glass medium. Okay. So angle of incidence is same as the previous case, but here the second medium is water, and here the second medium is glass. The ray is coming from same medium called air, having the same angle of incidence. Means the obliqueness of this ray is same. The first medium is same, but because the second medium is different, the deviation will be different. Because water and glass, if you compare these two, glass is more denser. So the speed of light decreases more as compared to speed of light decreases in water. So the bending, consider this is the original path which is not going to get followed. The bending of light ray will be towards normal, but that bending will be more than the first case. The refraction here is more as compared to heat. Refraction happens in both the cases because the light ray is changing the medium. Okay, but here the light ray goes from air to water and here from air to glass. So the change in speed will be more. Here, if you consider, just for the sake of understanding, the speed of light in air is 3 into 8, 10 raised to 8 meter per second. And consider here the speed of light is 2.3 into 10 raised to 8 meter per second. Okay, and here in glass, the speed of light will be 2 into 10 raised to 8 meter per second. So look at this. The difference of speed of light here is somewhat less as compared to this. Here the difference of speed of light is more. So more is the change in the speed, more is the refraction. More is the change in the speed, more is the refraction. So here glass is somewhat more denser as compared to water, so the refraction is more. So in this way, each and every medium, each and every medium has its own tendency, its own capacity to deviate the ray. Here glass is deviating the light ray more compared to water. So in this way, each and every medium having its own ability to deviate the ray. Like water is reflecting the ray here, glass is reflecting the ray here, but in this way, diamond, glycerin, kerosene, petrol, all the transparent media having its own tendency, own capacity to deviate the ray, and this capacity is symbolized or is denoted, is expressed in terms of refractive index. So refractive index is a number, is one of the number which gives you the idea that by how much the ray will be deviated. So refractive index is a number. One by one, step by step, you note something what I am telling you. Refractive index is one of the number. Nothing but the simple number. Now what this number will indicate you? Number will indicate you that what sort of refraction will be done, what amount of refraction will be done by that medium. Now how can we find that number? How can we find that refractive index? First of all, refractive index is of which medium? Refractive index is of which medium? Refractive index is always of refracting medium. See, this is incident medium and this is refracting medium. Incident medium, refracting medium. So in this case, just a minute. Okay, so refractive index is always of refracting medium. In the first case, refractive index is of water, and here is the second example, refractive index will be of glass. We have a common formula to find refractive index of any medium. Look at the formula. Refractive index of refracting medium with respect to incident medium. Refractive index is always of refracting medium. Refractive index is always of refracting medium with respect to incident medium. See, in the first example, refractive index will be of water with respect to air. In this example, refractive index will be of glass with respect to air. So the formula is refractive index is equals to speed of light in first medium upon speed of light in second medium. First medium means incident medium, second medium means refracting medium. So the speed of light of first medium. So look at it. So in this formula we can put the value. Speed of light in first medium means speed of light in air. The value is 3 into 10 raised to 8 meter per second. So in the numerator we will have speed of light in medium number 1 means 3 into 10 raised to 8 meter per second, and in the denominator speed of light in second medium means in this case the speed of light in water. In the second example, in the numerator we will have speed of light in air upon speed of light in glass. Right now we are not putting the values. So this is the very common formula to calculate the refractive index of any medium. Now, based on the incident medium, we have two kinds of refractive indices. Types of refractive index. First type is relative refractive index, and second type is absolute refractive index. Formula will be common. This formula of refractive index is common for both the types. These are the two types of refractive indices are based on incident medium. Condition for relative refractive index is if incident medium is other than air or vacuum. If incident medium is other than air or vacuum, and in the absolute refractive index, if incident medium is air or vacuum, no matter what refracting medium is, but if the incident medium is other than air or vacuum, let's have an example. Consider here is the interface surface separating two media. In the first medium is water and second medium is glass. In the second example, first medium is air and second medium is glass. So in these both the cases, if you see, refracting medium is glass, the second medium is common. So in these first or both the second case, refractive index will be of glass, because refractive index is always of refracting medium. So refractive index of glass, and here also refractive index of glass. Refractive index of refracting medium with respect to incident medium means here refractive index of glass with respect to water and refractive index of glass with respect to air. So here in the relative refractive index condition, if incident medium is other than air, so here the incident medium is other than air, and here the incident medium is air or vacuum, whatever you say. So in the first example, refractive index of glass with respect to water, and here refractive index of glass with respect to air. So if we are finding refractive index of any medium with respect to air, that is called as its absolute refractive index. So in this case, absolute refractive index of glass can be calculated, and in here the first case, relative refractive index of glass can be calculated with respect to water. Okay, so there are two types of refractive indices: relative refractive index and absolute refractive index. Now there are some symbols to denote refractive index. Refractive index is always symbolized by eta. Symbol for refractive index is eta. Okay. Speed of light. Speed are always symbolized by v. Okay. And already we seen in the previous lecture that the speed of light in air or vacuum is symbolized by c. The special symbol for speed of light in air or in vacuum. So it is c. So if you just write the formula in the symbolical form, refractive index of refracting medium. So refractive index means eta of refracting medium is medium number 2. So eta 2, eta of 2 means refractive index of medium 2 with respect to incident medium means with respect to medium number 1. So what do you mean by this symbol eta 2 1? How to speak it? Eta 2 1, or sometimes eta of 2 with respect to 1, whatever you say. So eta of 2 means it's a refractive index of medium number 2 with respect to medium number 1. Now that is equals to speed of light in medium number 1. So speed of light in medium number 1 means v1 upon speed of light in medium number 2 means v2. So what is this? It's the refractive index of medium 2 with respect to medium 1 is equals to speed of light in medium 1 upon speed of light in medium 2. So this is a symbolical form. So now the law will be completed here. What is the law? Ratio of sine of angle of incidence to sine of angle of refraction always remains constant. Let me complete this. Constant for given pair of media and the value of this constant is. So what is the value of this constant? Value of this constant is nothing but the refractive index of refracting medium with respect to incident medium. So refractive index itself is constant here. So how can we compute this law? Value of this constant is refractive index of medium 2 with respect to medium 1. So this is the complete second law of refraction, and this law is very famous as Snell's law. So these are the two laws of refraction. First one, incident ray, reflected ray and normal lies on the same plane. And second law, ratio of sine of angle of incidence to sine of angle of refraction always remains constant for a given pair of media, and the value of this constant is refractive index of medium 2 with respect to medium 1. Now let us write the whole statement in the mathematical form. Ratio of what? Ratio of sine of angle of incidence. So it is sine I by sine of angle of refraction means sine R, and that always remains constant. And the value of this constant is, so that is equals to refractive index of medium 2 means eta of 2 with respect to 1. So if you don't write this constant over here, that also it's okay. So what we can write? Sine I by sine R is equals to eta to 1. And this is the very important result we have to remember. Result number 1. So there are two types of refractive indices: relative refractive index, absolute refractive index. Please be careful, these are just the two types. The formula for both is common. These are the two types just on the basis of what? Just on the basis of the type of incident medium. The condition is if incident medium is other than air, that refractive index just called as what? Relative. And if the incident medium is air or vacuum, that refractive index is just named as absolute. Just the names are different, formula is same, and everything, the concept is totally same. Okay, so that's all for today. Best of luck.